All right, the time has come, my friends. This is the final exam. Listen, I know we had some like shortcomings with the exams, I know the last one's a pretty short blow for, unfortunately, a lot of the class, but this is it, this is our, final redemption. Just know that this final exam does take, if you get higher on this final exam than like any of your previous attempts at the exam, right? This would take the place of that exam. So like, this is kind of like a safety net, hopefully, hopefully you guys do good on this one, right? Because I know the last one was pretty bad, but it is what it is. So I picked out a couple of questions here. Well, it was a lot of questions actually, a lot more than I thought. But yeah, the same thing as last time. I'll just put timestamps in the things, go over each question, blah, blah, blah. But yeah, it was an absolute honor, an absolute pleasure to have you guys, yeah, I wish you guys the best of luck on this exam. Yeah, hopefully you guys understand this. Please, dear God, I hope you guys understand. But yeah, that's about it. Good luck in the exam, guys. See you. All right. So for number 2 here, we have solve the logarithmic equation. Be sure to reject any value that is not in the domain of the original logarithmic expressions. So here, right, the question is log base 4 of x minus 4, close parentheses, plus log base 4 of x minus 10 equals 2, right? So if we look at this, right, what do we notice? If we look at the question, right, we have what? We have a log base 4 here, right, and we have a log base 4 here. But there's no log base 4 on this side, right? So how do we go about like solving this question, right? So again, we have a log base 4 here and a log base 4 here. And we also have a plus, right? So if you remember, I believe it's called, I think it's like quotient rule or something like that, right? So basically, right, so we have 2 of the same bases here. We can just combine these 2 since it's like a plus here. So by combining, I mean like it's multiplication. So I'm gonna go ahead and rewrite this, right, as log base 4 of x minus 4, and then like this, x minus 10 equal to 2, right? Are we done here? No, right? So basically, I want to combine these 2 now. I just kind of brought them together here, but now I want to FOIL this, right? So I'm gonna get log base 4 of, so x times x is x squared, x times negative 10 is negative 10x, negative 4 and x, negative 4x, and then negative 4 and negative 10 give me plus 40. Equal to 2, right? And then I'm going to go ahead and take another step and just combine the like terms here. So I'm left with x squared. So we have minus 10 and minus 4. So we have minus 14 plus 40 equal to 2. So now, right, what's the next step here? Now I want to get rid of this log. But how do we do that with this, right? So basically, if you remember exponential form, right? What I'm going to take the base here and put like whatever's on the right side as our exponent equal to this. So here it's base 4, 2, and then x squared minus 14x plus 40. So this becomes 4, right? Base 4. Then we have our right side here is our exponent equal to this whole thing. So x squared minus 14x plus 40. Cool. So now what does this look like? So now we just square that. So this becomes 16 equals x squared minus 14x plus 40. And then here, right? So before we factor, we have to do what? Make this side equal to 0, right? So I'm gonna go ahead and subtract 16 from both sides, right? This becomes 0 equals x squared minus 14x. What is this, like 24, I think? 24? Yeah, it looks more right. So we're left with x squared minus 14x plus 24. So now that we have this whole thing equal to 0, right? Now we start factoring. So but now, how do we factor, right? So we would do 0 equals to parentheses, parentheses, parentheses. So now we need to find 2 numbers that give us 24, right? And also add up to negative 14. So if I do 24, right, and break up into 2 numbers, right? Let's say, like, what are the factors of 24? We have what? 24, 1, 12, 2, I guess like 8 and 3, right? Those are like our main 3. So now, right, if we add these up, right, Or I guess it would have to be like that. Because we have a positive number, right? But our addition part is negative here. So these numbers have to be negative. So if we add negative 24 and negative 1, right, what do we get? Equals to negative 25, right? And we have a negative 14 here. So this can't be it, so cross that out. We have a negative 12 and negative 2. This equals to negative 14, right? And look at that, we have negative 14 right here. So I'm just gonna go ahead and translate these numbers, right? Negative 12 and negative 2 into our parentheses here. So we have x minus 12 and x minus 2. Cool. And now, right, now that we have our factors, now we're just gonna go ahead and solve them. So if we put x minus 12 equal to 0, right, what number here would equal to 0? 12, right? So x is equal to 12 here, and then same thing with here, right? If we put x minus 2 equal to 0, what number here gives us 0? 2, right? X equal to 2. But now we're not quite done yet, because if you remember the question, right, it says, be sure to reject any value that is not in the domain of the original logarithmic expression. So the domain of log has to be, is what? X has to be greater than 0, right? Because can we have a 0 here? No, right? And we can't have a negative number either, right? So x has to be greater than 0 in this like parentheses. So here, right, if we plug in 12, right, into here, what do we get? We get 12 minus 4, right, equal to 8. So this is a positive number. That guy is fine. 12 minus 10 is what? 2, right? And that's also a positive number, so that's fine. So 12 is good. And we plug in 2 here, right? So 2 minus 4 is what? Negative 2. Oh, that's funny, right? We just find our domain was what? X is greater than 0. And here we had what? Negative 2, right? So automatically, if we have a negative number here, or like a 0, then like our answer here has to be wrong. And if we double check, right? So 2 minus 10 is what? Negative 8, right? So automatically we know that x equals 2 cannot be correct. So our only answer here that fits in the domain is x equals 12. Sorry, I just watched the replay and I saw like the bottom of the board's cut out, but basically here, we just have x equals 12 here and then x equals 2 here. So x equals 2 is just crossed out because we plugged into here and we got like a negative number, so yeah. All right, so for number 3, right, we have what? Find the domain of the function g of x is equal to square root x minus 1 over x minus 9. Okay, cool. So if we look at the function, right, what do we notice? We have a what? A fraction, right? And we also have a what? A square root on the top, right? So typically, right, for like fractions like these, right, our domain is usually just like pretty much determined by just the denominator, right? So first thing I'll do, right, is pretty much just take our denominator and set it equal to 0. So x minus 9 equal to 0, and then we solve this, right? So how do we isolate the x in this case? Just add 9, right, to both sides. So this is equal to x is equal to positive 9. Cool. But we're not quite done yet, right? Because what do you notice about the denominator? We have a square root. So we take the inside of the square root. So x minus 1, right? And for square roots, right, we know that we can't have a negative number in like the inside here, right? So our setup is going to look like this. So x minus 1 is greater than or equal to 0. Because if we have a 0 in the inside here, right, what do we get? So square root of 0 is like square root of 0, right? So square root of 0 is just 0. So we just consider solve this. So we have what? X minus 1 this side. So how do we isolate the x? Just add 1, right? So x is greater than or equal to 1. And so now we know that our x is equal to 9, and our x has to be greater than or equal to 1. So how do we start this, right? We do. So our first point would be like the 1, because x has to be greater than or equal to 1. And we have here x is equal to 9. So our first point is 1. It would usually be like, so our regular domain is like what? Like just negative infinity to like infinity, right? But in this case, we're like determined by x is greater than or equal to 1. So instead of like, you know, negative infinity to positive infinity, our first point would be 1, right? But is this parentheses or bracket now? It would be a bracket, right? Because what? There's an equal sign here. It's greater than or equal to. So bracket 1, right? And then what's our next point? 9, right? Because x cannot be equal to 9 here because what? 9 minus 9 is what? 0, right? And we know that anything divided by 0 is undefined because we cannot divide something by 0 because it just does not exist. So that's why 9 is our our point, or asymptote, sorry, our vertical asymptote. So it would be 1 to 9. And then we know that this is our vertical asymptote, and like the number cannot be 9 here because it would just be undefined. So this has to be a parentheses. And then union, right? And we start back over here. So 9 again. But not to what? We know that x is greater than or equal to 1. So we have 1 here, we got to 9. So pretty much we know that this is going to be infinity because it's any number greater than 1. And then with infinities, it's always going to be a parentheses. So our domain here is bracket 1, comma 9, union 9, comma infinity. All right, so for number 7, we have what? Form a polynomial whose zeros and degrees are given. So we are given 0 is equal to -8, comma multiplicity 1. Our second 0 is 1, multiplicity of 2. And then we're given degree of 3. Okay, I know it seems like a lot, right? Which it kind of is, right? But basically, right, so this 0, what does the 0 mean? They gave us -8, right? So essentially, if I were to plug -8 into something, like some sort of function, right, that -8 plugged in would give me a 0. So we're pretty much tasked of making some sort of function where -8 plugged in would give us 0. So they give us, -8. So if I were to like plug in, -8 to x plus 8, right, I would get what? A 0, right? So pretty much it's x plus 8, and then they give us multiplicity of 1. So multiplicity is usually just like the function, right? And like the exponent here. So they give us multiplicity of 1. So it's just x plus 8. And our second function is what? Our 0 is 1. So what function would I plug 1 into that gives me a 0? So pretty much just x minus 1, right? Except when I plug in 1 to here, I'll get 0. But here they give us what? Multiplicity of 2. Like that, right? And then we're given degree of 3. This is like the last thing we want to do here. But pretty much, right, I know that this is multiplicity 1 and this is multiplicity 2. So multiplicity 1 would just give me just x plus 8, right? Because 1 would just give me 1. X minus 1, though, has a multiplicity of 2. So this would look like x minus 1, right? Because this is being squared, basically. So what do I do now, right? I would FOIL this, because we have a parentheses, right? So again, so just FOIL. So x times x gives me x squared, right? X and -1 gives me -x. -1 and x gives me another -x, and then -1 plus 1, right? And then here I just want to combine my terms, so x squared, and then we have what? -x, so I'm just going to go combine them into a x squared minus 2x, right? And then just plus 1. So now, this guy is like that. So now, right, what do I do? Now I want to combine this one and this one. So it's going to look like x plus 8, and then x squared minus 2x plus 1. Just like that. And then now, what do I want to do? I have, what, again, a parentheses and a parentheses, right? So I'm going to FOIL again. Well, I guess this wouldn't be FOIL, but like, yeah, pretty much distribute, right, each term. So x and x gives me, or x and x squared, sorry, x cubed, right? X and -2x gives me -2x squared. X and plus 1 gives me a plus x. 8 and x squared gives me plus 8x squared. Plus 8 and -2x gives me -16x. Plus 8 and plus 1 gives me plus 8. And here I just want to rearrange terms, combine my terms, whatever, right? So this gives me x third. And then we have x squared here and x squared here. So we have -2 and plus 8. So I'm left with plus 6x squared, right? and then you have a plus x and negative 16x, right? So this gives me negative 15x. Ooh, that looks terrible. Give me 1 second. Oops. Negative 15x, right? Yeah. And then we're left with plus 8. So our polynomial that we just formed, right, is a 0 of negative 8. So if you plug in negative 8 to here, 0. And then we've 0 of 1, so plug in 1 here, 0. And then our degree is 3. And if we look at our highest term, what do we have? We have x to the third. Boom, degree of 3. And so this is everything. Yeah. Okay. Okay, so for number 8, we have use reference angles to find the exact value of secant of negative 3 pi over 4. Okay, so the first step I want to do, right, is to find where this angle lands. So I'm drawing a unit circle, right? We have what? Negative 3 pi over 4. So it goes negative pi over 2, and then negative 3 pi over 4. So something like that, right? So something like this, negative 3 pi over 4. And then we're asked to find the reference angle, right? So how do we find reference angle? Reference angle is from basically our coterminal angle, right? So our closest x-axis here is what? Negative pi, right? So I'm just going to do pi minus 3 pi over 4. So I'm left with pi over 4 as like the remaining angle between negative 3 pi over 4 and negative pi. So I'm just going to draw like a little arrow here and say this is, I guess I'll put it here, pi over 4, something like that. Negative pi over 4. So now we're trying to find the value of this. So I'll write out secant of negative 3 pi over 4, right? And then this would be just equal to like secant of negative pi over 4. Wait, no. So we notice these in like the third quadrant, right? So cosine here would be negative. So I think it's written out like this. Negative secant of pi over 4. Or I guess negative pi over 4. Something like that. I think that's how it's like. Yeah, so let's roll with that, I guess. So then if we take like the, I guess it could just be like that. Negative secant pi over 4. And then if I were to deduce, if I were to just like break secant into terms of like sine and cosine, right, it would look like negative 1 over, oops, this is cosine. So secant is just 1 over cosine, right, of pi over 4. So then cosine of pi over 4 is what? This would be square root 2 over 2, right? So this becomes square root 2 over 2. But remember, this is 1 over cosine. So that means that the value here has to be flipped because it's asking the secant, right? The secant of pi over 4. But we changed it to 1 over cosine, right? So when we have 1 over like cosine here, we have to flip this in respect to like this. So the values of the top and bottom are flipped. So this becomes negative 2 over square root 2, right? Like that. And then, but we have a radical in the bottom, so we can't do that. So we do this thing called rationalize. Basically, like we multiply the denominator, right, to the top and bottom again. So like square root 2 over square root 2 as multiply across. So now we're left with negative 2 square root 2 over, and then we have radical 2 times radical 2, right? So that means what? That means we can just kind of like cancel out those square roots, right? The radicals in this case. So it'd just be like 2, like that, because it's radical 2 times radical 2. So these just get canceled. So now here we have negative 2 square root 2 over 2. So that means we have 2 on top, 2 on bottom. So just cancel them out, and we are left with negative radical 2. And that should be the answer for number 8. Okay, and so for number 10, we have find the vertices and the foci for the hyperbola y squared over 25 minus x squared over 100 equals to 1. So the most important part, right, of this thing, right, is to identify what kind of hyperbola is it? Horizontal or vertical, right? So first thing I want to do, right, is look at this, right? So we have y squared over 25 minus x squared over 100 equals to 1. So if you guys remember, right, that to determine the hyperbola, we look at like the first term. So here we have y squared, right? So since y squared is positive in this case, right, that means that this hyperbola is going to be a vertical one. But in this case, or like, let's say like it was x squared over 100 minus y squared over 25, right? That means since x is like in the front, then that would be a horizontal, but it's not, right? So this is like a vertical. So I'm gonna write that down. So this is a vertical hyperbola because y squared is positive. Chicken scratch, I know, but it is what it is. So how do we find the vertices, right? So vertices are just like the these numbers squared. So we have what? Y squared over 25, right? So if we were to square 25, right, like that, this would give us plus and minus 5. So, and we know that this is a vertical hyperbola, right? So that 5 gives us a vertice on the y-axis. So our points here would be just 0. Let's do positive first. So 0, 5, and 0, negative 5. Oops. Negative 5. Okay, and then likewise, right, we're going to do x squared over 100, right? And then take the 100 and square that. So this gives us plus or minus 100, right? So this is plus or minus 10. And it's x, right? X over 100. So this means that the horizontally, right, it's 10. So our new vertices are, so this is our x, right? So this is 10, 0. Or I guess it would be appropriate to like put the negative, oh actually, I already messed up the order, but let's do negative 10, 0, and then 10, 0. So these are our vertices, right? So our vertices are negative 5, 0. Oops, wait, hold up. Oops, I got myself confused here. 0, negative 5, 0, 5, negative 10, 0, and positive 10, 0. Bam, vertices. Easy, right? But now foci, right? So foci for hyperbolas are the formula for it. So it's going to be foci, oops. Foci squared is equal to what? Big plus small, right? So we're just going to take, plug these values in, right? So write out again, foci squared is equal to big, so 100, plus small, 25. So foci squared is equal to 125, and then we're going to square both sides here, right? So this leaves us with foci is equal to plus or minus. Remember, when we square things, it's always plus or minus. So plus or minus square root 125. I believe the answers, they actually like simplify this. So I'm going to go ahead and do that. So 125, right? What does that look familiar to? It looks like 25, right? So basically, if we take 25 times 5, so it look like imagine 25 times radical 5, like that. Okay, my 5s are horrible. So 25 times radical 5, right? But this 25, if we were to square the 25, right, we'd get 5. So we kind of get rid of the square root here, or the radical. So this becomes plus or minus 5 radical 5, like that. Oh my god, that is horrible. 1 second. Boom. So our foci is plus or minus 5 radical 5. So foci, right, we know that this is a vertical hyperbola. So this is going to be like our y-coordinate. So if I write this out, right, this would be 0, negative 5 square root 5, and 0, positive 5 square root 5. So these are foci, and these are vertices. Okay, I just looked at the answer key real quick, and they actually don't have the negative 10, 0, and the 10, 0 here listed in the answer key. But they are important though, because with like the negative 10 to the 10, right, we make like little box thing. That's how we get our transverse axes. So it'd be like that, right? And then connect them corner to corner, like that. I don't know why it's not listed in the answer key here, but those are important because I guess we'd ask for transverse axis and stuff like the rise over run stuff, but I don't know why it's on here. But yeah, just keep that in mind. Okay, and so for question 11, we have solve 3 to the x plus 6 equals to 8. So here, right, I'm trying to look for a relationship between this base and this base. Unfortunately, right, 3 doesn't really go into 8. Like if we do 3 squared, it'd be 9. 3 to the 1 power is just 3. So unfortunately, we have to do this the hard way, right? So what's the first step here? If the bases don't really match up to each other, what can we do? How do we like bring this exponent down as a coefficient? Well, we can ln both sides. So just kind of ln 3x plus 6 equals to ln of 8, right? So now, since both sides are ln, we can bring this exponent down as a coefficient now. It becomes x plus 6 ln of 3 is equal to ln of 8. So since this parentheses is like kind of isolated already, we can just divide both sides by ln of 3 here. So this becomes x plus 6 equals ln of 8 over ln of 3, right? And now to completely isolate the x, what can we do? We just subtract the 6's, right, from both sides. This becomes x equals ln of 8 over ln of 3 minus 6. So here I'm going to tweak the problem a little bit so like we get like the easier version, right? So I'm going to change this 3 to a 2 instead now. So it becomes 2x plus 6 equals to 8. Now, right, can we establish a connection between the 2 and the 8? Yeah, right. So if we imagine this 8 as 2 to the third power instead, right? Because 2 times 2 is 4, and then 4 times 2, 8. So if I were to just do that, so this becomes 2 to the x plus 6 equals 2 to the third power. Now, since we have the same bases on both sides, right? So we have a 2 and a 2 here. I can just kind of take the top terms, right, and make them equal to each other. So this becomes x plus 6 equal to 3. Yeah? So I guess I can just cross that out like that, right? So how do we isolate the x? We just subtract 6, right? So this becomes x equals negative 3. Just like that. But yeah, this is like kind of what we want to learn here. But yeah, this is just like the easier version. Okay, so for question 15, we have complete the identity sine squared x plus sine squared x times cotangent squared x. So I'm just gonna write it down here, right? Sine squared x plus sine squared x cotangent squared x. Boom. Okay, so I kind of have to go in order here, right? So, well, actually, I can just split this into terms of sine and cosine, right? So it becomes sine squared x plus sine squared x times, and what's cotangent again? What's the order? It's cosine of x squared over sine squared of x, right? So if I were to multiply this sine, right, to this, it would just be sine squared. Oh, actually, I'll write that out. Hold up. Sine squared x plus, so this becomes sine squared x cosine squared x. Remember, if I multiply a whole number to a fraction, right, it just goes up to the top, basically. So this is just sine squared of x at the bottom, just like that, right? And what do we notice? We have a what? A sine squared x up here and a sine squared x down here, right? So we can just kind of cancel them out, and we're left with what? Cosine squared of x over 1. So this becomes like that, sine squared of x plus, oops, I'm just getting a little ahead of myself here, cosine squared of x. So, and what do we know that this guy is as? What do we know this guy as? There we go. So, one of our Pythagorean identities, right, is equal to what? 1. So, And that's like the exact form, right? Sine squared x plus cosine squared x equal to 1. Just like that. Okay. And so for question 16, we have find and simplify the difference quotient for f of x equals x squared plus 9x minus 2. Okay, so difference quotient. Do we remember what that is? Well, the reminder, right? So pretty much it could either say like, simplify the difference quotient, right? Or it could be like, oh, find the f of x plus h, right? So the whole formula for difference quotient is f of x plus h, right, minus f of x all over h. So let's take this formula and just plug it in, right? So our f of x is what? It is f of x equals to x squared plus 9x minus 2. So how do we get the f of x plus h? So all I'm going to do is just kind of, for every x here, I'm just going to put in x plus h now. So here, right, our first x, so x plus h squared plus 9x plus h minus 2. So let's go ahead and do that, right? So x squared, x plus h squared. So x, or I guess I'll write out the whole thing, right? X plus h plus 9, x plus h minus 2. Okay, so let's FOIL here. So x and x gives us x squared, right? X and h gives us xh, or let me do xh instead. Let's just keep constant, put x in the front, right? So again, h and x gives us another x plus h, or xh, sorry. And then h times h gives us h squared. All into a little parentheses, and then here we have, let's distribute the 9, right? So 9 and x gives us 9x. 9 and h gives us 9h minus 2. Okay, so, and I guess let's write out f of x as well. So this whole thing minus x squared plus 9x minus 2. All right, cool. So let's go ahead and actually let's distribute this this negative first, right? So this would give us, let's keep that there. So this would give us what? A negative x squared, right? So let's give us a 9x squared, negative 9x squared. Oh, not x squared. And then negative and negative gives us a plus 2. So let's go ahead and combine all of our like terms, right? So we have x squared plus xh. Oh, this becomes 2xh, sorry. Plus 2xh, right? Because we have xh here and xh here. So just combine them, 2xh. Plus h squared plus 9x plus 9h minus 2 minus x squared minus 9x plus 2. All right, so let's start and just kind of cross things out, right? So we have an x squared here and a negative x squared. So cross that out, right? Let's see, what else do we have? We have a minus 2 and a plus 2. Cross that out. We have a plus 9x and a negative 9x. Boom, boom. And so what are we left with? We are left with 2xh plus h squared plus 9h, all right, and then all over h. So let's go ahead and cross this guy out, h, and I want to cross out the 2 here because there's 2 h's here, and there's only 1 here. So this becomes 1h now, and this guy crossed out. So now we're left with 2x plus h plus 9. And so that should be our answer. Let me double check. This is question 16. Yes, 2x plus h plus 9. Okay, so for number 17, we have use properties of logarithms to expand the logarithmic expression as much as possible. Where possible, evaluate logarithmic expressions without using a calculator. Okay, so we have this big old thing, right? So log base 7 of the whole thing, x to the 5 times y over 49, and a radical of radical 4? No, radical 1/4, I guess. Anyways, so how do we approach this, right? So we have what? Log base 7 and 49, blah, blah, blah. All right, so first thing I want to do, right, is kind of get rid of this fraction, right? I want to do, I forgot what it's called. Oh my God. difference quotient, I think it's called, right? So I'm gonna, since this is like a division question, right? This basically means subtract. So I'm gonna write out log base 7, right? And we have this whole thing over like the 1/4 radical. So I'm gonna keep that. So this becomes 4, and I have x5 y minus log base 7 of 49 to the 4. So again, how did I do this, right? This is difference quotient. So this is like our denominator here basically means this whole thing is getting subtracted, right? So I just kind of move this guy out by himself, right? So same thing here, same thing here. So what's the next plan? What's the next plan, right? So we have here a product rule, I think it's called, yeah. So again, same thing, right? Well, not the same thing, but this, like the division was subtraction, right? This multiplication of between x5, x to the 5th, and y is like addition. So same thing, I'm gonna write out the whole thing. So x to the 5 plus log 7 of, what was it, y? So 4y minus log base 7, 4 of 49. Okay, cool. So now I want to get rid of this like square root looking thing, right? So the 4. So basically, this like 4 here means that the exponent inside of this whole thing, right? So like imagine there's like a whole parentheses here, is the power of 1. It's an imaginary 1, right? And like the 4 is on the outside. So to convert this guy into a fraction, right? What I can do is put log base 7 and put this whole thing x to the 5, right? To the power of 1/4. Yeah? So I'm gonna do the same thing here, log base 7 of y to the 1/4 minus log 7 of 49 to the 1/4. So here I'm going to go ahead and bring this exponent to the front as a coefficient now. So, but in this case, right, I have what? X to the 5th, right? This 5th, I can kind of just like multiply it to the top here. So this becomes 5 over 4. You get me? So now it's 5 over 4 log base 7 of x. And here, there is no exponent inside the y, so it's just 1/4. So plus 1/4 log base 7 of y minus 1/4 log base 7 of 49. And here, right, we have what? Log base 7 and 49. This can just simplify to 2. So this becomes, or I guess I'll do it here. Right? So like basically this is like 1/4 2, like that. And if I multiply, this becomes, what is it, like 1/2? Yeah, that looks about right. So if I write this out again, 5 over 4 log base 7 of x plus 1/4 log base 7 of y minus 1/2. And let me double check the answers here. Number 17. Yes, that is right. Okay, and so for question 20, we have find the summation of 1 to 5 of k to 10. Okay, so I know those intimidating, right? It's a giant E, right, with a bunch of numbers. So what this means basically, right, is that we want to find the sum of all of these values, right? So we plug in from 1 to 5. So 1, so like 1, 2, 3, 4, and 5. So we pretty much plug in each value, right, to here, and we add them all together. So if we plug in 1 to here, we get what? -9, right? 1 minus 9, -9, -9, 2, -8, -7, -6, -5. Because it's just basically just one difference, right, every time. So we found that's -9, -8, -7, -6, -5. Add this all together, right? So we have what? 9 and 8 becomes 17, -17. 7 and 6 becomes what? What is that? 12? No, 13? Yeah, 13, sorry. And then -5. So -17, -30, -30, oh, -35. Oops. Simplify that. Oh my god, that is horrible. Okay. Negative 35. Okay, did the same thing, but you get the gist. Basically, just easy. So just take each thing. So we start at 1 and go to 5. So 1, 2, 3, 4, 5. And then just add all the values together like that, negative 35. Okay, and so for question 24, we have find the cosine of theta given that tan theta is equal to negative 2 over 3 and that theta is in quadrant 2. Okay, so first thing we know that is the theta is in quadrant 2. So our triangle here is going to look like this. So this is theta, right? So, and then we're given that tan is what? Negative 2 over 3, right? So tan is opposite over adjacent. So negative 2 over 3. So where does that negative belong? We know this is quadrant 2, right? So if we know that we draw quadrant 2, right? Yeah, so this is like positive, positive, and this is what? Negative, positive, right? Because it's quadrant 2, and so on and so forth. Yeah. Boom. Okay, so this means that this is positive 2 over negative 3 because of this, right? Just this is y over x, so y over x. Okay, and so now we're given to find cosine of theta. So we're missing the hypotenuse here, right? So we want to find that out. But now how do we achieve that? Pythagorean theorem, right? So Pythagorean theorem is like so. A squared plus b squared equals c squared. So let's do a, right? So a is just 2 squared plus negative 3 squared equals 2c squared. So 2 squared is 4. 4. Negative 3 squared, 9 equals c squared. 13 equals c squared. Square both sides, and we're left with c is equal to plus or minus square root of 13. Cool. But remember, right, that this is hypotenuse. Hypotenuse can only be positive. So just erase that negative. And we're left with square root of 13. And so now cosine is just what? Cosine is just adjacent over hypotenuse, right? So if we do that, so cosine of theta is equal to what? Adjacent is negative 3. Negative 3 over hypotenuse, we just found its square root of 13. Cool, but we're not quite done yet, right? Because unfortunately there is a square root at the bottom, or a radical on the denominator. So we have to rationalize them. How do we rationalize them? We take the denominator here, so our radical, and multiply the top and bottom of itself. So top and bottom, square root of 13, boom. So if we multiply across, what do we get? We get negative 3 square root 13 over, so radical 13 times radical 13 equals 13. And so our cosine here is negative 3 radical 13 over 13. Let me double check that. What is that, 24? 24, it is, yes indeed. Okay, and so for question 25, we have log of x plus 30 minus log 3 equals log 2x plus 1. Okay, so what's the first thing we notice? We have log, log, and log. And there's no basis, right? But just know that when a log is by itself, it's actually just log base 10, but it's just kind of invisible, right? So we notice log, 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 so we can just combine these two, right? So it's going to be x plus 30 times, or actually no, this is what is it called? Difference quotient, something like that. So this would be like a minus, right? So it's actually like this. It's actually division equals to 2x plus 1. So I'm going to want to go ahead and get rid of the 3, right? So I'm going to multiply both sides by 3. So these cancel out, and this becomes x plus 30 is equal to what? So 2x times 3 is 6x, and then 1 times 3, 3. Cool, so I'm left with x plus 30 and 6x plus 3. Cool, so let's go ahead and move this 3 over to the left and this x over to the right. Actually, I'll take it one step at a time. So it's 30 equals to 5x plus 3. And then I'm going to go ahead and move this 3 over, so it becomes 27 equals 5x, and then go ahead and divide. So x is equal to 27 over 5. Boom. Okay, so question 29 asks, what's the domain of f of x is equal to x minus 2 over x, x cubed minus 36x. Okay, cool. So again, right, it's a fraction, right? So our main domain, our main concern, right, is like pretty much just the denominator. So I'm gonna go ahead and take the denominator and put in 2 equal to 0. X, my bad. X cubed minus 36x equals 0. Cool. So what do we notice, right? There's an x cubed and an x here, right? So I'm gonna go ahead and factor this guy out. So it's x squared minus 36. Cool. All right. And so what do we notice about this, right? X squared minus 36. But what's special about that 36? He's a perfect square, right? So, but it's also a difference of squares. That's the term I was looking for. So, difference of squares, right? So if we remember, it's x plus 6, right? Because 36 is 6 times 6, right? So we have a plus 6, and then we have a minus 6 equal to 0, right? And then now we just solve. So x is equal to 0 here, x is equal to negative 6 here, and x is equal to 6. So we have our three zeros, right? So what's the domain now? So our domain is what? Negative infinity, right? To what now? To negative 6, right? Because that's our lowest point. But is it now a parentheses or a bracket, right? Because remember, if we plug in negative 6 here, what do we get? We get a 0, right? So 0 times 0, 0, whatever. So 0 is on the bottom. But we can't divide by 0, right? Because that's like undefined. So we can't have like a negative 6. So this has to be a parentheses, right? Union, negative 6 again, to what now? To 0, right? Again, right? This is going to be a parentheses because we can't have 0 here. 0. So union, 0 to what now? To 6, right? To 6. Same thing, parentheses. You get the gist now. 6 to infinity. Boom. All right, so okay, so for 27, it says a building 260 feet tall, right? So 260 feet tall casts a 100-foot long shadow. If a person looks down from the top of the building, what is the measure of the angle between the end of the shadow and the vertical side of the building? Assume the person's eyes are level with the top of the building. Okay, cool. So let's just draw a standard triangle, right? So something like that, along the lines of that, right triangle. That's pretty bad, but yeah. Okay, so 260 feet tall. So assume the size of the building, right? Cast a 100-foot long shadow. So this is our shadow here. And then the person looks down from the top of the building. So our angle is here. This is our theta. And what is the measure between what is the measure of the angle between the end of the shadow, so here, and the vertical side of the building, so here? Yeah, so we're looking for this like angle depression kind of, right? Okay, so pretty much, right? Like, well, what they gave us here is what? In terms of the angle, right? So angle, they gave us the adjacent and the opposite and the adjacent here. So if we write this out, right? So like tan theta is equal to what? Opposite is 100 and adjacent is 260. 260. Boom. Right? But now we're tasked to find the angle. What is the angle, right? So if we were to rewrite this, right, into an inverse, right, we can like isolate the theta by itself. So if we were to swap places between the theta and like our fraction here, right, it would look like tan inverse of whatever's here. So 100 over 260 is equal to theta. And so this would be like, this is pretty much our calculator ready form, and then you would just plug that into the calculator, get a number back, and yeah. But yeah, that's pretty much it. I know it's like a word problem, so not that, yeah, whatever. Okay, and so for question 30, they were giving us a triangle, right? So they gave us what? Let's start with A, right? So they have little a is equal to 8, little b is equal to 5, and little c is equal to 4. So they basically gave us a side angle, or side triangle, sorry. So this is gonna be a formula, right? I don't really remember this one, but essentially, right, so we're gonna take, let's say we were trying to find A first, right? So like angle A is equal to, so we take the other two sides, so let's do B first. So this would be B squared plus C squared minus, and whatever like side we're starting off where we're trying to find with, so A squared all over 2, and then the two sides that we have that are not this one. So b and c in this case, right? So we're just going to plug in the values now. So angle A is equal to b squared. So b is equal to 5. So 5 squared plus c squared is 4. 4 squared minus a is 8. 8 squared. All over 2. B is equal to 5. 5. And then c is equal to 4. So something like that. I would just leave it like that, honestly. Like that's a lot of numbers. But yeah, we'll do the other sides though. So b in this case, right? So again, so we're starting with b. We want to find b. So we'll take the other two sides that are not b. So a and c. So a squared plus c squared minus the one that we're looking for. So b squared in this case. All over 2, and then the two that are not related to b. So a and c in this case. Again, just plug in the values, right? So a is, oh my god, that is horrible. Give me 1 second. Would be 8 squared plus c squared is 4. 4 squared minus b, which is 5. 5 squared all over 2, and then it's what, AC? So a is 8, and c is equal to 4. Again, I'll leave it there, and then let's do c. So again, the two that are not related to c, or the two that aren't c, if that makes any sense, a squared plus b squared minus the one that we're looking for, c squared, over 2, and then the other two that are not ab, or that are not c, so ab. So plug in the values again. A is 8 squared plus b, which is 5, 5 squared, minus c, which is 4, minus 4 squared, all over 2. A is 8, and b is 5. So again, yeah. Now I would just leave it like that. Like that's a lot of numbers and stuff, number crunching. So just leave it like that. Let me double check the answers. Oh, they want to do Oh, okay. So they would just do, why is it cosine? Hold on. Oh, this is log cosines. There we go. Yeah, there we go. So this is just like cosine inverse of this whole thing, right? So 5 squared. You get the gist. Just, although I'll just kind of include that. So A is equal to cosine inverse of this whole thing. And that's like equal to theta right here. So same thing here, I would just do B is equal to cosine inverse of this whole thing. And likewise here, C is just equal to cosine inverse of this whole thing equal to theta. Yeah. That is, yep, that's right. Oh, there's a negative. Oh, my bad. Negative, 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 negative. Yeah. Okay, and so number 3, it's asking, find the vertical asymptotes of the function h of x plus 2 over x squared minus 4. Okay, again, right, vertical asymptotes, pretty much kind of like the same thing as domain, right? So again, it's a fraction, so just take our denominator and equal to 0. X squared minus 4 equal to 0. Boom, okay. 4. We know that guy is a square of 2, right? So this is just another difference of squares question. So this is going to be x, right? And then 4 is made up like it's 2 squared, so we have to do an opposite. So let's do x plus 2, and then the opposite of it. So x plus 2, x minus 2. Boom. And then equal to 0, right? So this becomes negative 2. This is 2. X equals 2. Okay, and then vertical asymptotes, right? So how do we put this into words? Well, actually, that's it. Yeah, the vertical asymptotes are just x equals negative 2 and x equals 2. Okay, correction on 33. So in the answer sheet, it's only on the positive 2. Yeah, so they only give us positive 2 because at x equals negative 2, right, if we plug that in, it'd be 0 at the top. So 0 divided by, 0 is a 0. So it's like I think it's a whole or something. I don't know. But basically, yeah, our only asymptote here is x equals 2 because if you plug in negative 2 here, it'd just be 0. So yeah, slight mistake there. Okay, so for 36, it's asking solve this thing, right? So x plus 3, 5 minus x, greater than or equal to 0. Okay, so I would just put them all to 0, right? So x equals 0, x plus 3 equal to 0, and then 5 minus x equal to 0. So x equals 0, this is x equals negative 3, and then, okay, so let's put this over here. So 5 equals x, so x equals 5. And then now, right, it's greater than or equal to 0. So I'm just going to go ahead and draw our number line. So we have negative 3, 0, and 5. So here we're just testing values to see like the positive or the negatives, like, you know, the trend of the graph, right? So first point is negative 3. So let's take something to the left of it. So negative 4, right? So negative 4 to here. So where's that like? Okay, hold up. Let's do negative 4. Okay, so first value is negative. So negative 4 plus 3, also a negative. And then 5 minus negative 4 is a positive. But we have negative, negative, positive. So negative, negative, positive, and then times a positive. So this is positive. Boom. All right, and then a number between negative 3 and 0. So I'm going to do negative 1 here. Negative 1, right? So negative 1 outside, negative. Negative 1 plus 3 is a positive. And then 5 minus negative 1 is another positive. So we have a negative times a positive, negative, and then that negative times positive, negative. Boom. Okay, and then 0 and 5, the number between 0 and 5. So I'm going to do 1. Right? So 1, plug it in, positive. 1 plus 4, or 1 plus 3 is 4, so positive. And then 5 minus 1 is positive. Boom, positive. And then we do 6 here, because it's 5 to infinity. And we do 6. Okay, so 6, positive. 6 plus 3, positive. 5 minus 6, negative. So positive, positive, positive. And then a positive times a negative. So boom. And then the question is asking, you know, what x's are greater than or equal to 0? So we have this guy and this guy, right? Because they have to be positive. So how do we write this out, right? So we would do from like this side. So this is negative infinity, right? To this point. So negative 3. But now, right, is it a parentheses or a bracket? So if we look here, right, it's a greater than or equal to. So bracket. Because we plug that in, we get a 0, blah, blah, blah. Yeah. So it's a negative 3, right? And then our next point is from 0 to 5. So 0, 5, right? And then again, is it a bracket or parentheses? And we know that it's a greater than or equal to, so bracket. Just like that. And that should be it. Let me check. 36. Yes, that is right. Okay, so for question 37, it's giving us use transformation to graph f of x, negative 2 to the power of x plus 4 minus 3. I'm not going to lie. If I saw this exam, anyways, so we want to determine the domain, range, and find the equation, the horizontal asymptote. Plot at least 3 points. Basic function. Then use it. Yeah. Okay. So our basic function, right? So our parent function is what? Parent function is, if we look here, right? What do we have? We have a negative 2 to the x plus 4 minus 3. So we know that this is what? A horizontal shift, right? And we know that this minus 3 is a vertical shift, and then this minus is a reflection. So that leaves us with 2 to the x. So our parent function is f of x equals 2 to the x. Boom. Okay. And then, okay, so parent functions, let's graph that out. Right. Let's do a little x and y table. So I would take one negative number, so negative 1, I would do 0, and then like 1 or something, right? So negative 1, right, here would be like what, 1 over 2. 0, which is 1, 2 to the 0 is 1, and 2, or any number to the power of 0 is 1. And 2 to the 1 is 2. I guess I'll do one more. I'll do 2, just to have like another point. Okay, so negative 1 is 1/2. 1/2, 0, 1, and then like 1 and 2 is here, and like 2 to the 4 is somewhere here. So our general trend is looking something like that, and then this number touches. But know that, you know, in these exponential graphs, right, that there is a horizontal asymptote at 0. So y is equal to 0. Or, yes, y equals 0. Because this line, this graph never touches. Because we can go like in the infinite like negative direction, like any number negative, right? Like negative 100, and it's gonna be like a really small like fraction, but it'll never touch that x-axis. Okay, so parent function done. So what's our next transformation? We have a horizontal shift, right? So horizontal shift. Okay, so I guess I would ask like how many units and where. So we have what? X plus 4, right? So x plus 4, what does that mean? It means we're moving 4 units to the left. Because we do pretty much the opposite of whatever it's telling us here. So plus 4 would like be here, right? But no, we're actually going to like here. So 4 units to the left. Boom. And then what would that look like? What would the function look like? It would be y equals f of, oh, oops. Don't mind that. It's f of x equal to 2, and then our parent function was what? 2 to the x, right? And then 4 units to the left is just plus 4. X plus 4. Okay. And then drop that out. Yeah, that's fine. That's fine. And then x or y values. So pretty much just choose like just take this, take the x's, right, and just minus 4. So negative 1 minus 4 is just negative 5. Negative 5, right? And then 0 minus 4 is just negative 4. Negative 3, negative 2, you get the gist, right? And then same values here, just apply. So 1/2, 1, 2, and 4. So negative 5, 1/2, 4 to the 1, 3 to the 2, and negative 2 to the 4th. Okay, that looks a little too linear, but you get the gist. It's like something like that. And then again, for this one, right? I put y equals 0 here, but I do like this like dotted line, dash line thing, just to show us a horizontal asymptote, just so I know, and like the instructor knows. So I'll do the same thing here. Dash line, y equals 0. Boom. Okay, next transformation is reflection, right? So this is reflection, but where is this reflecting across, right? Because look at the position of this, right? It's a negative in front of the whole thing. So what does that mean? It's reflecting over the x-axis. So over the x-axis. So basically, any value you plug in here, right? It'll end up being negative anyways because there's a negative in front of the whole thing. So that means pretty much any value here would just be kind of flipped down here because it's negative now. So reflection over the axis, and then our function would look like what? We take our last one, right? So, well, I guess the reflection's in the front, so it'd be negative, and then whatever the last one was. So 2x plus 4. Boom. Okay. And then again, graph it out. So our x, y values, what can we do, right? So I'm going to take the same x values we took here. So negative 5, negative 4, negative 3, negative 2. And then what changes in the graph? It's the y values, right? Because any value you plug in here would just end up being negative. So I'm going to take the same y values here, right? But just make them negative. So the first one I had was 1/2, so negative 1/2. And then I have negative 1, negative 2, negative 4. Again, I'll graph it out. So I'm just going to like eyeball it. So this is like negative 5, 1/2, 4, 1, 3, 2, and then negative 2 is like 4 down here somewhere. So it looks like that kind of. And then again, our asymptote is y equals 0 because we did a horizontal shift and a reflection. So that horizontal asymptote just stays the same. So now our final transformation is a vertical shift, right? Because the negative 3. Vertical shift, right? And then we have a negative 3. So what does that mean? We're going 3 units to the bottom, or we're going moving down 3 units. 3 units down, I'll say. And then our function would look like what? F of x is equal to, I'll take the same one we did here. So f of x equals negative 2 x plus 4, right? And then what changed? Negative 3, right? So negative 3. Okay, again with the graph, and then x, y values. So what changes, right? So I'm going to take our x values, the same thing, negative 5, negative 4, negative 3, negative 2. And then I want to move our y values down 3 now. So pretty much take this, right, just minus 3. So 1/2 or negative 1/2 minus 3 is negative 3 1/2. So then negative 1 minus 3 is negative 4. Negative 4, negative 2 minus 3 is negative 5. And then negative 4 minus 3 is negative 7. So negative 5, 3.5. I'll say like 4s are on here. 3, negative 5, 2, negative 7, something like that. But now what changed? What changes with like the vertical shift? Our horizontal asymptote, right? Because you can't leave it all the way up here because then it doesn't really make sense. So let's imagine this is like, I know the graph is really bad, but it is what it is. Let's just say like that line is our horizontal asymptote. So y equals what? Negative 3, because this horizontal asymptote was y equals 0, and it moves along with the graph. So minus 3 units down. So from 0 to negative 3. And let me just double check our graph here. What is this, 37? Yeah, that looks all right. Yeah, well, I think they graphed, no, it would look like that. Yeah, that's fine. Okay, so for 38a, we have 1 plus sine squared of 20 degrees plus sine squared of 70 degrees. Okay, so what do we notice, right? We have sine 20 and sine of 70, right? If we were to add these up, right, what would they get us? It would give us 90, right? But, you know, we can't just add angles like this, right? But we can change one of them to have, like, you know, something else. So what I'm trying to get out of here, right, is, let's say I were to change this, right, like a coterminal, I think it's called coterminal angle, something like that, right? So I'll do like this, right? So I'm going to change the sine squared to like cosine squared of 90 minus this. So minus 90 minus 20 degrees. So this gives us, yeah, then plus sine squared of 70 degrees, right? So this would give us 1 plus cosine squared of 70 plus sine squared of 70. Boom, right? And now it's our favorite friend. It's cosine squared of theta plus sine squared of theta. It's the same angle, right? So that just becomes 1. So it's just 1 plus 1 equals 2. There we go. So part C, we have cosine 55 sine 35 plus sine 55 cosine 35. Cool. So when we see stuff like this, all right, anything that's a multiplication of like a sine and a cosine sign, right? Please, for the love of God, just look at the formula sheet. If this looks anything close to like something on the formula sheet, it's probably it, right? I guess on the formula sheet would be like, what was it, like cosine of like A, and then like sine B, right? Something like that, sine plus cosine of B, sine A. It would look like that on the formula sheet, right? So what do we have? We have cosine of A, you know, sine of B, right? It's a different angle. Cosine of the B, right? Or wait, hold on. Yeah, well, it's flip. Yeah, so this is the sine of the A. So A and A is 55, right? And the B is 35. Yeah, it matches up, right? Please, I know you guys struggled a little bit on these kind of questions. Please, if you don't, if it looks something like you know, it's multiplications, like plus something, right? If you don't understand it, just look at the formula sheet. It, like, most likely it's gonna be somewhere on there, right? And it's better, you know, to look there and, you know, put some bullshit than, you know, just leave it blank. So, right? So back to this. So this is like, this is equal to, I'm gonna say this is like sine of A plus B. I'm pretty sure, I don't remember the cosine ones, but I'm pretty sure this is sine A plus B. So, right, if I were to do that, so alpha plus beta, so sine of 55 plus 35, right? So 55 plus 35, what is that, like 90? So sine of 90. Wait, let me double check the answers just to make sure. I'm on the right page here, 38. What is this? the sine of 90 degrees, yeah, it's 1. So that's 0, 1. Yeah, so equal to 1. Boom. Yeah. I mean, like, we give the okay, and so for 39, it says, suppose sine of alpha is 4 over 5, right? And A is in quadrant 1. Then cosine of beta is equal to 5 over 13, and B is in quadrant 4. Find the exact value of sine alpha plus beta. So sine of alpha plus beta. This is, what is this? That's it, okay. So first thing I want to do is just draw the triangle, right? So we know it's quadrant 1, so it's going to look something like this. This is theta, right triangle, and they gave us opposite over adjacent, or opposite over hypotenuse, sorry. So 4 over 5, right? And then cosine of beta, we have, quadrant 4. Quadrant 4, so our angle, or a triangle looks something like this, theta, and then 5 over 13, 5 over 13. Boom, okay. And then sine of alpha plus beta, okay, well, first we'll figure out the triangle, right? So again, we have opposite and we have hypotenuse. So we want to find the adjacent, right? So I will do a squared plus b squared equals c squared, good old Pythagorean theorem, right? So 4 squared plus b squared equals 5 squared, 16 plus b squared equals 25. What is that, like 9, I want to say? B squared equals 9. Yeah, I'm pretty sure it's 9. So b squared is equal to plus or minus 3. Square both sides. Yeah. So, but we know it's quadrant 1. So this side has to be positive because it's positive in quadrant 1, yada yada. Yeah. So, okay, and then here we're missing our opposite. We have adjacent and hypotenuse. So let's do 5 squared plus b squared equals c squared. So 25 plus b squared equals, this is 13, 169. So b squared equal to 144. Square both sides. B is equal to plus or minus 12. Okay, but now we're in quadrant 4, right? So we know that quadrant 4 is, what's the values, like x and y values? It's what? Positive and negative, right? So this has to be negative. So negative 12. Because it's our y. Yeah. So, and then sine of a plus b, right? What was the formula? Oh my god, we just had it. I think it's like sine alpha plus beta is equal to sine a cosine b plus sine of b cosine a, right? So sine a is what? So first triangle, sine was 4 over 5. 4 over 5. Cosine of b was 5 over 13. 5 over 13 plus sine of beta, which was negative 12 over 13. Negative 12 over 13. And then cosine of a was 3 over 5. 3 over 5. And multiply together. 4, 5, 20. What is that, 65? Yeah, pretty sure. This is negative 36 over 65. 20 minus 36 is negative 16 over 65. What is that, 39? Let me double check. 39 is negative 16 over 65. Yes. Okay, and so for 43, it's just asking us to find the exact value of these like angles, right? So tan of pi. So if I were to draw it out, tan of pi, right? So what are our points here? It's negative 1, 0. So this would just be sine of pi over cosine pi. So plug in the values, we have 0 over negative 1, boom, 0. Tan of pi over 2, right? So pi over 2. So our points here would be what? 0, 1. So this would be sine over cosine pi. Oh, pi over 2, sorry. Sine pi over 2. So we know that this is 1 over 0. Can we have a 0? No. So this is undefined or definite. Just like does not equate or something like that. So back to here. sine of pi was what? It was what, or our coordinates here was 0, 1, right? And we know that sine is just based on our y value, so this is just equal to 1, easy. Cosine of 3 pi over 2, so pi over 2, pi, 3 pi over 2, we have 0, negative 1. Cosine is just our x, so equal to 0, easy. Okay, so for question 44, we have our function, oh, wait, what? Okay, yeah, oh, this is supposed to be a y here, oops. Y is equal to 2 cosine of 2x plus pi over 4. Okay, and it's asking us what is the amplitude? Amp, period, phase shift, final key points, and graph. Okay, so again, right, so I'm gonna write out our model formula, right? So y equals a, then cosine bx, oops, this is minus c. Bx minus c. Okay, cool. Oh, plus b. And then I match it up, right? So our a here is what? 2, right? And then our b is equal to 2 as well. And then now I want to find period, right? So period is the formula. Period is equal to 2 pi over b. And we found b is here, is equal to 2 pi over 2. Cross the 2's out, and we're left with pi. Period is equal to pi. Okay, and then our c here is what? Pi over 4, right? But it's like minus, so it's minus pi over 4. Oh my god, I'm losing it. Minus pi over 4, negative pi over 4. God damn, okay. And then we don't have a midline here. Oh, wait, right, phase shift. Phase shift is equal to c over b. And we just found our c is negative pi over 4, and our b is 2, right? So we have a fraction divided by a whole number. In this case, right, we take the whole number and we just kind of multiply it into the denominator here. This becomes negative pi over 8. That easy, right? Phase shift, negative pi over 8. Okay, and then so we found amp, found period, found phase shift, and now final key points. So before we find the key points, right, we need to find our what's it called, parent function, basic function. I don't know the terminology right now. Cosine of x, because they gave us cosine, right? So y equals cosine of x. So how do we get the basic function, right? Our basic function looks like, what is it like? Like that, right? Has 1 point here, 2 point here, 3 point, 4 point, 5 point. And then you might be wondering, right, how do we get these points? So these come directly from the unit circle. So unit circle, right? So our first point, right, our first angle is what? We start at 0, right? So angle is 0, right? And then our coordinate here is what? 1, 0, right? So our x coordinate, our cosine, right, is 1. So 0, 1. So angle, and then our value at that angle. So move on to pi over 2, right? Pi over 2. And then what's our coordinate here? We have 0, 1, right? So our x coordinate at this point is 0. Pi over 2, comma 0. Moving on to pi, right? Because we pretty much do every 90 degrees or every like pi and a half, right? So here, what's our coordinate here? We have negative 1, comma 0. So we have pi, comma, negative 1. Wow, these are like egregious hieroglyphics here. Anyways, moving on. So we have 3 pi over 2, right? Coordinate is 0, negative 1. So it's 3 pi over 2, and then 0, because our x coordinate here is 0. And then our final one is 2 pi, because we did a full rotation, right? 2 pi, and we started off back at 1. So 1. Yeah, that's like, I hope that's like, that explains a lot, kind of. But yeah, these are like a given. These are always going to be the key points for our base function of y equals cosine of x. Anyways, moving on, right? So, final key points. So this is basic key points. Okay, basic key points, and then this is final key points. Okay, how do we get final key points? So our first coordinate, right, is always going to be our phase shift. So negative pi over 8, right, because we found this from C over B, negative pi over 8. So this is our first x coordinate, or our angle, right? Negative pi over 8, and then how do we find the y value, right? So we had 0, 1 in this first like bracket, or first coordinate, right? We want to take our amplitude. So we have 2 here. So 2 times 1 is 2. Boom. That's simple. Next coordinate is, oh right, I keep forgetting this. Okay, so our period we found here was pi, right? So we have a formula for like to find the next couple of points. So it's, hold on, oops. I don't know the name right now, but it's period over 4. This means that we're cutting the period up into four parts, right? Because we know our first initial like coordinate, right? But now we need to find the next 4, because there's 5 total points. So this is our formula. So period over 4. So we found period is equal to pi over 4. There we go. So now we just take pi over 4 and just add it to this. So negative pi over 8 plus pi over 4. And then if we put this in terms of pi over 8, right, it would be negative pi over 8 plus 2 pi over 8. This leaves us with pi over 8. Boom. So pi over 8 is our next angle, or coordinate, whatever, right? And then we had here, it was pi over 2, comma 0. 0 times 2, our amplitude is 0. Boom. And then again, right, so pi over 8 plus 2 pi over 8 from like this. So we just add, every like new x coordinate we get, we just add like this to get the next one, and so on and so forth. So pi over 8 plus 2 pi over 8, same thing as pi over 4, right? So this becomes 3 pi over 8, comma, here a third set of coordinates is pi, comma, negative 1. Negative 1 times 2 is negative 2. Okay, and then 3 pi over 8 plus 2 pi over 8, 5 pi over 8. 5 pi over 8, go up to here, we have 3 pi over 2, comma 0. 0 times 2, 0. And then our final key point is 5 pi over 8 plus 2 pi over 8. 7 pi over 8, comma, 2 pi, comma 1, 1 times 2, 2. Boom. And now to graph it out, right? Let's do something like this. I know, okay, so our first point was negative pi over 8, and our last point is 7 pi over 8. So I'm going to do pi here and negative pi here, because this does not complete a whole pi, and this doesn't complete a whole pi either. So now I just divide this up to eight like intervals. 1, 2, 3, 4, 5, 6, 7, and then 8 is the last one. 1, 2, 3, 4, 5, 6, 7. Let me just, oh, we're not going this way, it's fine. So, and then amplitude is what, 2? So I'll do 2 here. Boom. So this is 2, negative 2. All right, and now let's graph, right? So negative pi over 8, 2. First like interval is negative pi over 8, and then 2. Pi over 8, comma 0. 3 pi over 8, comma, negative 2. 1, 2, 3, negative 2. 5 pi over 8, 1, 2, 3, 4, 5, comma, 0. 7 pi over 8, so 5, 6, 7, comma, 2. Boom. And now just connect the dots, right? Something along the lines of that, and that's it. So we satisfied the amplitude, the period, phase shift, find the key points, and finally our graph. Sometimes I might ask to do like the parent graph, like do like dotted lines, so let's go ahead and do that. So 0, negative 1, or oops, 0, 1, 0, 1, pi over 2, 0, so 1, 2, 3, 4, because there's 8 intervals here, right? And this is like, 4 pi over 8, pi over 2, same thing. And then pi, negative 1, something around here. And then we don't have the space to do it, but it'd be something along the lines of, that, kind of, and then it would like go back out. But yeah, that's the general gist of it. This is like pretty much the complete thing you need to do. Pretty straightforward, I hope. I mean, I know it's graphing, you know, it is what it is. But yeah, that's it for this graphing cosine.